Hello everyone and welcome to this channel Lucid Mind Chemistry with Majid. In this video I'll be discussing Chemistry A-Levels Multiple Choice Paper 1 Variant 1 from May-June 2019. You can skip to any question by following timestamps given in the video description. Feel free to give any comments, likes and shares to this video. Also, you can subscribe for more upcoming videos. Let's start solving. Question number 1. The temperature of a sample of an inert gas is increased. What effect does this have on the number of molecules with the most probable energy and on the number of molecules with high energy? We can solve this question by using Boltzmann distribution. In Boltzmann distribution, the curve is drawn like this. On y-axis we have number of molecules. And on x-axis we have energy of molecules. At normal temperature the curve is like this. Now this curve has two parts. One is this one. This one shows the number of molecules with most probable energy. And second portion is this one, which shows the number of molecules with high energy. When the temperature is increased, what happens that as the area under the curve is constant, so this curve will move in the right direction. Now we can see that the number of molecules with most probable energy have decreased and the number of molecules having high energy have increased. So therefore in the first part we have decrease and in the second part we are going to show increase. The answer is therefore B. Question number 2. A sample of element X is analyzed using mass spectrometry. The mass spectrum obtained is shown. On y-axis we have percent abundance of the isotopes and on x-axis we have mass to charge ratio. Now we can see that three peaks are given. One is of 3% abundance, second is 114 with 56% and third one is having atomic mass 115 and 41% abundance. What is the relative atomic mass of this sample of element X? Now we can use the formula for relative atomic mass. So relative atomic mass is equal to isotopic mass into percent abundance of first isotope plus again isotopic mass into percent abundance of second isotope and so on, divided by 100. Let's put the values. For first isotope, the isotopic mass is 112 multiplied by percent abundance, which is 3%. Similarly, for second isotope, we can see that the atomic mass is 114 into percent abundance, which is 56%. And for third one, it is 115 into 41%. Divided by 100. The values are 336, 6384, 4715. Now the value of relative atomic mass comes equal to 114.35. The answer is therefore D. Question number 3. A washing powder contains sodium hydrogen carbonate as one of the ingredients. In a titration, a solution containing 1 gram of this washing powder requires 7.15 centimeter cube of 0.100 mole per decimeter cube sulfuric acid for complete reaction. The sodium hydrogen carbonate is the only ingredient that reacts with the acid. What is the percentage by mass of sodium hydrogen carbonate in the washing powder? We can find percentage by mass by using this formula. It is equal to the mass of sodium hydrogen carbonate in the sample divided by the mass of washing powder, which is given, multiply by 100. Now what happens is that sodium hydrogen carbonate reacts with sulfuric acid in a complete chemical reaction. We can find the number of moles of sulfuric acid that is required. So we have the volume and we have the concentration in mole per decimeter cube. We can find the number of moles of sulfuric acid by using the formula. Number of moles is equal to concentration in mole per decimeter cube into volume in decimeter cube. Concentration is given as 0.100 mole per decimeter cube and volume is given as 7.15 centimeter cube, which can be converted into decimeter cube by dividing by 1000. Now the value for number of moles of sulfuric acid is 0.000715. Now we can write the balanced chemical equation between sodium hydrogen carbonate and sulfuric acid. NaHCO3 reacts with H2SO4 to form sodium sulfate along with water and carbon dioxide. Let's balance this chemical equation. We have 2 sodium atoms on the product side, so we can write 2 with the reactant. Now number of carbon on the reactant side is 2, so we can write 2 with carbon dioxide. Now balancing hydrogen, we have 2 hydrogen atoms in this compound and 2 in this one. So in total we have 4 hydrogen atoms on the reactant side, so we can write 2 with H2O. The number of oxygen atoms are now already balanced. So now according to this balanced chemical equation, we have 2 moles of NaHCO3 that reacts completely with 1 mole of sulfuric acid. Now the number of moles of sulfuric acid obtained in titration is 0.000715. So we can write 0.000715 for sulfuric acid. And let's calculate by cross multiplying the number of moles of NaHCO3 comes equal to 0.000715 into 2. The answer is 0.00143 moles of NaHCO3. In percentage by mass formula, we are going to use the mass of substance, not the moles. So let's first convert this number of moles into mass. The formula is mass is equal to moles into MR. The molecular mass of sodium hydrogen carbonate can be calculated. We have 1 sodium atom, which is 23, 1 hydrogen, which is 1, 1 carbon, 12, and 3 oxygen atoms that combine together to form 48. So in total the atomic mass is 84. Putting in values, the number of moles is 0.00143 into molecular mass, which is 84. So the mass in grams of sodium hydrogen carbonate come equal to 0.120 grams. Now let's put these values in the percentage by mass formula. So mass of NaHCO3 obtained is 0.120 grams divided by the mass of washing powder, which is given as 1 grams, into 100. It comes equal to 12%. Therefore answer is C. Question 4. The outermost electron in an atom of neon occupies a particular orbital. Which row shows the relative energy and shape of this orbital? Let's do the electronic configuration of neon atom. For neon, the number of protons is 10. So we can write 1s2. 2s2, 2p6. Now we can see that the outermost electron is present in p subshell. Now p orbital is dumbbell in shape. And p orbital has high energy as compared to s orbital. So we can see the shape. This is dumbbell shaped, so this is correct. And the energy of orbital relative to other occupied orbitals, as we have s orbital as the other occupied orbital, so therefore the energy of p is higher than s. So we can write higher or equal. The answer is therefore A. Question 5. In which species is there a lone pair of electrons? A is CH3. In CH3 there is no charge that is given, so it means that number of protons are equal to the number of electrons. As carbon has 4 electrons in the outermost shell, so we only have one unpaired electron. There is no lone pair of electrons present. The definition of lone pair of electron is that it is such a pair of outer shell electron that is not involved in bonding. For B we have CH3. Again we can draw the structure. We have 1 carbon atom, 3 hydrogen atoms. As we have positive charge, it means that 1 electron is lost. So we can cut out this electron. Now you can see that there is no lone pair of electrons present. So B is also incorrect. In C we have CH3 negative. Again 1 carbon atom and 3 hydrogen atoms. As carbon is in the 4th group, so there are 4 electrons in the outermost shell of carbon. And also we have a negative charge, which means that we have extra electron present in outer shell. So we can see that lone pair is present. So C could be correct option. In D the formula is CH4. So as all electrons are involved in bonding, so there is no lone pair of electron present. The only correct option is therefore C. Question number 6. When an evacuated tube of volume 400 cm3 is filled with a gas at 300 Kelvin and 101 kilopascals, the mass of the tube increases by 0.65 grams. Assume the gas behaves as an ideal gas. What could be the identity of the gas? Now different gases are present in the answer. We can identify the gas by calculating the molecular mass of the gas, and then we can find out which gas is present. We can use the formula PV is equal to nRT, where P is the pressure in pascals. So P is equal to 101 kilopascals, so we can convert it into pascals by multiplying by 1000. Volume is in meter cube, as it is given in centimeter cube, so we can convert the volume into meter cube by dividing by 1 exponential 6. It is equal to 0.0004 meter cube. N is the number of moles, and the formula of moles is equal to mass divided by molecular mass. So we can rewrite the equation PV is equal to mass divided by molecular mass into R into T. By rearranging the equation, we can find the value of molecular mass. Mr is equal to mass into R into T divided by pressure into volume. R is the ideal gas constant, and the value of R is equal to 8.314. pascals into meter cube per Kelvin per mole. Last one is temperature. Temperature is already given in Kelvin, so we can write T is equal to 300 Kelvin. The mass of the gas is also given, which is 0.65 grams, so we can write mass is equal to 0.65 grams. Now putting all these values in the equation, mass is 0.65, R is 8.314, temperature is 300 Kelvin, pressure given is 101,000 pascals, and volume is 0.0004 meter cube. The values come equal to 1621.23 divided by 40.4, which is equal to 40.12. Now this is the MR of the gas that is used. From periodic table we can find out the molecular masses. So the molecular mass of argon is 39.9, for helium it is 4.0, for krypton it is 83.8, and for neon it is 20.2. The nearest value is 39.9, so therefore answer is A. Question number 7. Under which conditions will nitrogen behave most like an ideal gas? There are few properties of ideal gas, among which we have that the distance between the molecules is very large as compared to the diameter of the molecules, and second is that there are no forces of attraction or repulsion present between the molecules. Now we can see that the effect of temperature is that if we increase the temperature, what happens that the kinetic energy of the molecules increase and the intermolecular forces are reduced. So the temperature must be high for ideal gas situation. Similarly, for pressure, we know that at high pressure the molecules come close together and therefore intermolecular forces are developed, but in ideal gas there are no forces of attraction, so therefore the pressure must be very low. So therefore at high temperature and low pressure the gas will behave like an ideal gas. The answer is therefore B. Question number 8. Two reactions and their enthalpy changes are shown. This is the first chemical reaction and the enthalpy change is given as plus 52.2, and in second we have negative 175.8. These data can be used to calculate the enthalpy change for the reaction shown. Now this is the reaction for which you have to find the enthalpy change. What is the value of X? Now there are two different methods for solving this question. In the first one we are going to use Hess's law by drawing a triangle. As the product is common, so we can write this one as product. So we have C2H4 gas that is being formed. Now there are two different types of reactants. One are the elements in their standard states. So we can write carbon solid and hydrogen gas, which react together to form this product. In second formation we have C2H2 that reacts with the hydrogen to form the same product. So we can write C2H2 gas plus hydrogen and the same product is formed. Now these elements can also combine together to form these reactants. So we can draw the arrow like this. Let's balance. We have 2 carbon atoms and 2 hydrogen. The rest is already balanced. By applying Hess's law, we can see that the elements first convert into reactants and then reactants convert into products. So this is a 2-step process. And if elements directly convert into the product, then this is 1-step process. Now we have to calculate the enthalpy change, that is in the formation of C2H2 from carbon solid and hydrogen gas. So this is this one. So therefore this arrow is the one that we are going to find. Let's give it value del H1. For second arrow we can see that C2H2 combines with hydrogen to form this product, and the enthalpy change is already given, which is negative 175.8. So we can write minus 175.8. Third reaction is the combination of carbon and hydrogen to form C2H4 gas. The enthalpy change is already given, which is plus 52.2 kilojoules per mole. Now applying Hess's law, the energy change in 2 steps is equal to the energy change in 1 step. So we can write del H1 plus negative 175.8 equals plus 52.2. Now finding value of del H1, the answer is 228. It corresponds to part D. Now using second method, the first reaction is carbon solid reacts with the hydrogen gas to form C2H4 gas. In second reaction, C2H2 gas reacts with hydrogen gas to form C2H4 gas. And in this reaction, we can see that carbon solid is present, which is a reactant. So we can see that this one was reactant. Again, hydrogen is given as a gas. Now hydrogen is also given as gas at 2 points. And C2H2 gas is given as product. Now we can see that C2H2 is not the product in the given reaction, but it is also a reactant. Now in order to make this C2H2 gas as product, we have to reverse this second chemical equation. Now rewriting first and second equation, we can write 2 carbon solid plus 2 hydrogen gas forms C2H4 gas. The enthalpy change is plus 52.2. Now we have to reverse the second equation to make C2H2 is product. So we can write C2H4 gas convert to C2H2 gas plus hydrogen gas. And if we are reversing the equation, we also have to reverse the enthalpy change. So the enthalpy change will become positive 175.8. Let's combine these two equations. First, cut out the ones that are similar. So we have hydrogen on the reactant side and on the product side. We also have C2H4 on the product side and on the reactant side, so they will be cut out. Now adding the remaining, we have 2 carbon solid. 1 mole of hydrogen gas is also left, so we can write H2 gas, and the product is 1 mole C2H2. Let's add the enthalpy changes. So the net enthalpy change is 228. Now this equation is similar to this one. Therefore the energy change is X, which is actually equal to plus 228. The answer is therefore D. Question number 9. Ethane dioic acid, in which we have 2 carboxylic acid functional groups present, can be oxidized by KMnO4, which is an oxidizing agent, in dilute sulfuric acid. The products of this reaction are carbon dioxide, water, potassium sulfate, and manganese 2 sulfate. In this reaction, each ethane dioic acid molecule loses 2 electrons as it is oxidized. A half equation for this process is shown, so we can see ethane dioic acid is converting into carbon dioxide along with 2 protons and 2 electrons. How many water molecules are produced when 5 ethane dioic acid molecules are oxidized by KMnO4 in dilute sulfuric acid? Now as ethane dioic acid reacts with KMnO4, so KMnO4 is itself reduced, while ethane dioic acid is oxidized. Now you can find the equation for the reduction of KMnO4 in electrode potential values in data booklet. So from data booklet, the equation is MnO4 negative plus 8H positive plus 5 electrons. It converts into Mn plus 2, which is actually reduction, plus 4H2O. Now we can see that in this equation Mn has converted from +7 to +2, so therefore KMnO4 has been reduced. As in the first equation, we can see that 5 electrons are gained, while in the equation of ethane dioic acid only 2 electrons are lost. So let's balance by equalizing the number of electrons lost and gained. So we can multiply the first equation with 2 and second equation with 5, so that the total number of electrons become 10. So now we have 10 electrons gained by potassium manganate and 10 electrons lost by ethane dioic acid. So it means that the equations are balanced. Now we can see that 4 water molecules were formed earlier, and now when it is multiplied by 2 it becomes 8 H2O molecules. Also we can see that when multiplied by 5 the ethane dioic acid molecules also become 5 in number. So for 5 ethane dioic acid molecules, 8 water molecules will be formed. Therefore answer is B. Question number 10. Hydrogen iodide gas decomposes reversibly, producing iodine vapor and hydrogen. The enthalpy change is also given, which is plus 12 kilojoules per mole. The position of equilibrium for this reaction may be altered by changing the external conditions. Which row correctly describes the change in position of equilibrium? First is the increasing the pressure, and second is increasing the temperature. Let's look into the number of moles of the reactants and products. So we can see that 2 moles of HI gas are decomposing. So it is 2 moles on the reactant side, and 1 mole of iodine and 1 mole of hydrogen gas is formed. So therefore there are 2 moles of product that are being formed. As the number of moles of reactant and number of moles of product is equal, so therefore there will be no effect of pressure on the position of equilibrium. This is because pressure will affect the reactant and product in equal manner, so therefore there is no change. Second thing is the increasing of temperatures. As we can see that the reaction is endothermic. So for endothermic reaction, if temperature is increased, what happens that the reaction moves in the forward direction and the position of equilibrium also moves to the right. This is because endothermic reaction require energy in order to convert into products. So if you are increasing the temperature, the reaction will move forward. If you are decreasing the temperature, the equilibrium will move backward. The answer is therefore C. Question number 11. The reaction between sulfur dioxide and oxygen is reversible. Again, the equation is shown. Kc for this reaction is given as 280 per mole decimeter cube at 1000 Kelvin. In an equilibrium mixture at 1000 Kelvin, the sulfur trioxide concentration is 6 mole per decimeter cube, so it is SO3. The sulfur dioxide concentration is twice the oxygen concentration. What is the sulfur dioxide concentration? Let's use the formula for equilibrium concentration Kc. So Kc is equal to concentration of product, which is SO3, raised to the power its number of moles, which is 2, divided by the concentration of reactants, which is SO2, raised to the power its number of moles, and multiplied by the concentration of oxygen, raised to the number of moles, which is 1. As sulfur dioxide concentration is twice the concentration of oxygen, so if the concentration of oxygen is taken as X, then sulfur dioxide will be 2X. Let's put in the values. Kc is 280. SO3 is 6 mole per decimeter cube. SO2 is 2X. And oxygen is X. So it will become 280 is equal to 36 divided by 4x square, which then multiplied with x becomes 4x cube. Now rearranging, x cubes is equal to 36 divided by 4 into 280. The value is 0.0321. Now taking cube root on both sides, we can find the value of x. So x is equal to 0.3178. So this is the concentration of oxygen. As the concentration of sulfur dioxide is double, so we can find 2x, which will come equal to 0.3178 multiplied by 2, 0.636. The answer is therefore D. Question number 12. 1.15 grams of a metallic element needs 300 cm³ of oxygen for complete reaction under room conditions to form an oxide which contains O-2 ions. What could be the identity of this metallic element? The mass of metallic element is given, which is 1.15 grams. As for calcium, the atomic mass from periodic table is 40.1. For magnesium, it is 24.3. For potassium, it is 39.1. For sodium, it is 23.0. Let's find the number of moles of each of these elements that are given. As number of moles is equal to mass in grams divided by atomic mass. So for calcium, the number of moles come equal to 0.0286. For magnesium, it comes equal to 0.0473. For potassium, the values is 0.02941. Similarly, for sodium, the number of moles come equal to 0.05 moles. Now A and B is calcium and magnesium, which come from group 2 of the periodic table, while C and D is potassium, which come from group 1 of the periodic table. Let's find the number of moles of oxygen that is given. So the number of moles is equal to volume in centimeter cube divided by 24,000. So the number of moles come equal to 0.0125. For reaction of group 2 elements with oxygen, we can write metal from group 2 reacts with oxygen to form metal oxide. As the charge on group 2 is +2 and the charge on oxygen is -2, so therefore the formula will be MO. Now balancing this chemical equation, we have 2 moles of product. Now oxygens are equal on both sides, so we can write 2 with M in order to balance this 2. So as the ratio between the metal of group 2 and oxygen is 2:1. Now the number of moles calculated for oxygen is 0.0125. So the number of moles of M that would react would be X. Now finding the value of X, we can cross multiply. So the number of moles of metal in group 2 comes equal to 0.0250, that reacts completely with oxygen. Now we have 2 values and none of them is equal to 0.0250. Now doing the same procedure with group 1. For group 1, the metal is M. It reacts with oxygen to form metal oxide. Now as the oxidation state of group 1 is +1, so the formula of oxide will be M2O. Now we can balance this chemical equation, first balancing number of oxygen atoms, then balancing number of metal atoms. Now the ratio between metal and oxygen come equal to 4:1 from balanced equation, and from given number of moles it is 0.0125, so we can find the moles of metal by cross multiplying. X comes equal to 4 into 0.0125. and it comes equal to 0.05 moles. Now looking at the number of moles of group 1, this one seems to be correct. The answer is therefore D. Question 13. The relative melting points of 4 consecutive elements in periodic table are shown in the graph. The elements all have proton numbers less than 20. Which element is in group 16? Now the element present in group 16 could be of period 3. As in period 3 we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. Now the atomic number of sodium is 11, for magnesium it is 12, 13, 14, 15, 16, 17 and 18. Now looking at melting point for sodium, which is in group 1 of the periodic table, then we have magnesium which is in group 2 of the periodic table. As the number of outer shell electron increase, so therefore the melting point also increases from sodium to aluminum. In aluminum, metallic bonding is stronger as compared to magnesium, which is stronger as compared to sodium. This is because sodium just loses 1 electron while magnesium can lose 2 electrons and aluminum can lose 3 electrons. So now higher the number of electrons lost, greater will be the charge. So greater will be the force of attraction between the atoms. For silicon, we can see that silicon does not make metallic bond, it forms giant covalent compound. So therefore the melting point of silicon is greater than aluminum. Now phosphorus is a nonmetal and it occurs in the form of a molecule of 4 atoms, while sulfur exists in the molecule of 8 atoms, chlorine exists in the molecule of 2 atoms and argon is single. As we know that for larger molecules the intermolecular force of attraction is greater because there are greater number of electrons, so therefore the melting point of phosphorus will be less as compared to the melting point of sulfur. Again in chlorine we can see that only 2 atoms are present in the molecule, so therefore the melting point will reduce. Again for argon, which is single, there are no forces of attraction, so therefore the melting point will reduce further. So we can see that after silicon the melting point dropped, and then for sulfur it increased, and then for chlorine and argon it decreased further. Now looking at this graph, the melting point is 273, which is equal to 0 degrees centigrade. As B and C have higher melting point as compared to 0 degrees centigrade, so it means it is not gas. So it could be phosphorus and sulfur. Then chlorine melting point is very low as compared to sulfur, so D could be chlorine. While the melting point Fa is very high, so it could be silicon. Among these 4, sulfur is present in group 6 of the periodic table, so the answer is C. Question 14. Substance X reacts with water, a gas is given off and the pH of the solution increases. The solution is then reacted with sulfuric acid and a white precipitate forms. What could be substance X? A is barium. Now barium is a reactive substance and it can react with water to form barium hydroxide. Along with hydrogen gas. As barium hydroxide is highly soluble in water, so therefore it will increase the pH. And also hydrogen gas is being produced. So both assumptions are correct. A gas is given off and pH increases. So we can do the second reaction with sulfuric acid to see whether a white precipitate forms or not. So now barium hydroxide reacts with sulfuric acid and it forms barium sulfate and water. As barium sulfate is solid and it is insoluble and it is also white in color, so therefore option A could be the correct option. B is barium oxide. Now barium oxide is a base and it dissolves in water to form barium hydroxide. Now no hydrogen gas is released in this process, so therefore B is incorrect. C is magnesium. It reacts with water to form magnesium hydroxide. Now magnesium hydroxide is less soluble as compared to barium hydroxide, so therefore it will make weakly alkaline solution. Along with hydrogen gas, let's do second reaction of magnesium hydroxide with sulfuric acid. Magnesium hydroxide plus sulfuric acid, it will form magnesium sulfate along with water. Now magnesium sulfate is soluble in water, so therefore it won't give a white precipitate. So C is also incorrect. Again in D we have base, which is magnesium oxide. So magnesium oxide will dissolve in water to form magnesium hydroxide, which is weakly alkaline, and no hydrogen gas is produced, so therefore D is incorrect. The correct answer is therefore A. Question 15. Solutions of 0.1 mole per decimeter cube magnesium nitrate and 0.1 mole per decimeter cube barium nitrate separately undergo a series of reactions using pure reagents. First reaction is magnesium nitrate aqueous reacts with sodium carbonate solution to form M, which then reacts with excess HCl to form N, which reacts with excess sodium hydroxide to form P. Similarly, barium nitrate aqueous reacts with sodium carbonate first to form Q, then in excess HCl it forms R, and in excess sodium hydroxide it forms S. M, N and P are magnesium compounds. Q, R and S are barium compounds. How many of M, N, P, Q, R and S are white precipitates? Now magnesium nitrate can react with sodium carbonate and exchange of ions take place, so therefore magnesium nitrate will become magnesium carbonate. Then magnesium carbonate can react with HCl to form magnesium chloride along with water and carbon dioxide, which is N, and magnesium chloride can react with excess sodium hydroxide to form magnesium hydroxide, which is P. Similarly, barium nitrate can react with sodium carbonate to form barium carbonate. Then barium carbonate can react with HCl to form barium chloride, which can react with sodium hydroxide to form barium hydroxide. Now finding the solubility of the substances that are formed. The first one is magnesium carbonate and it is insoluble, so therefore it is in the form of white solid. So it could be M, which is white precipitate. Second is magnesium chloride, which is N and it is soluble, so therefore it is not forming white precipitate. Third one is magnesium hydroxide. Now the solubility of magnesium hydroxide is very less, and when excess sodium hydroxide is added, what happens that magnesium hydroxide precipitates out in the form of insoluble white substance. So it could be P. Now Q is barium carbonate, which is white precipitate in the form of solid as it is insoluble. So it could be Q. Again, barium chloride is soluble as was magnesium chloride, so it is not R. And we have barium hydroxide, which is highly soluble in water and it forms alkaline solution, so it is not S. So only M, P and Q form white precipitates. As these are 3 in number, so therefore answer is B. Question 16. Concentrated sulfuric acid is added to separate solid samples of sodium chloride, sodium bromide and sodium iodide. With which samples does sulfuric acid act as an oxidizing agent? Now 3 salts are given. One is sodium chloride, second is sodium bromide and third is sodium iodide. All of these react with sulfuric acid concentrated to form product, which is sulfate. Sodium chloride forms sodium hydrogen sulfate with concentrated sulfuric acid. Sodium bromide also forms sodium hydrogen sulfate. Sodium iodide also forms sodium hydrogen sulfate. The second product in case of NaCl and concentrated sulfuric acid is HCl. In NaBr, the second product formed is HBr. In sodium iodide reaction, the second product formed is HI. So far, no change in oxidation state have occurred. For example, sodium was +1, it is still +1. Cl was -1, it is still -1. Similarly, sulfur in H2SO4 was +6, it is still +6. So sulfuric acid has not yet acted as oxidizing agent. Upon further reaction, we can see that HCl is not oxidized by concentrated sulfuric acid because there is no reaction. As sulfuric acid is unable to oxidize HCl. While HBr can be oxidized by concentrated sulfuric acid into products, the reaction will be HBr plus sulfuric acid. It will form bromine, sulfur dioxide and water. The oxidation state of bromide in reactant was -1, while in bromine it is 0. So from -1 to 0 it is called oxidation. While sulfuric acid, sulfur was +6, which is converted into SO2, in which oxidation state is +4. So this is reduction. So it means that upon reaction with sodium bromide, concentrated sulfuric acid does behave as an oxidizing agent. The third reaction is with iodide, and iodide can also be oxidized by concentrated sulfuric acid. The reaction will be like this. As in the reaction, we can see that iodide has changed from -1 to 0. So again it is oxidation. And sulfuric acid has shifted from +6 to +4, which is reduction. So we can say that upon reaction with sodium iodide, concentrated sulfuric acid does behave as oxidizing agent. A. Sodium chloride only. This is wrong. B. Sodium chloride and bromide. This is incorrect. C is sodium bromide and sodium iodide. So C is the correct answer. Question 17. The reaction of bromine with warm sodium hydroxide aqueous produces products with the same oxidation numbers in the same ratios as the reaction of chlorine with hot sodium hydroxide. In one reaction between bromine and warm NaOH, 30.2 grams of product containing sodium, bromine and oxygen is produced. Which mass of sodium hydroxide has reacted? They have given a hint of disproportionation reaction in which chlorine reacts with hot sodium hydroxide. So the reaction of bromine will be the same and the molar ratios are also same. So we can write the balanced equation. As in hot alkali, chlorine reacted with sodium hydroxide to form sodium chloride, sodium chlorate and water. The molar ratios in balanced equation were 3, 6, 5, 1 and 3. The reaction of bromine will be similar, so we can write for Br2, 3 moles of Br2 will react with 6 moles of sodium hydroxide to form 5 moles of sodium bromide along with sodium bromate and 3 water molecules. Now we can see that in the question they have given 30.2 grams of product which contains sodium, bromine and oxygen. So it is this one. The mass is 30.2 grams. Which mass of sodium hydroxide has reacted? So we have to find out the mass of sodium hydroxide. Let's take the ratio between them. We have sodium hydroxide and sodium bromate. According to balanced chemical equation, 6 moles of sodium hydroxide form 1 mole of sodium bromate. Let's find the number of moles given in the question. So we have mass which is given as 30.2 and molecular mass of NaBrO3 will be, it is 23 for sodium, 79.9 for bromine, and for 1 oxygen it is 16, so for 3 oxygen it will be 48. So the total molecular mass of sodium bromate is equal to 150.9. We can find the number of moles as moles is equal to mass in grams divided by molecular mass. So mass in grams is 30.2 and molecular mass is 150.9. So number of moles are 0.2 moles. We can put this value in the ratio given. So we can write 0.2 moles of sodium bromate is formed from X moles of sodium hydroxide. So by cross multiplying, X is equal to 6 into 0.2, which becomes 1.2 moles of NaOH. Now in the question they have asked about the mass. So mass is equal to moles into MR. For sodium hydroxide, we have 23 for sodium, 16 for oxygen, 1 for hydrogen. So in total the molecular mass comes equal to 40. So we can write 1.2 for number of moles and 40 for molecular mass. So mass in grams come equal to 48. The answer is therefore D. Question 18. At 550 degrees centigrade, nitrogen dioxide reacts with unburnt hydrocarbon fragments such as CH3 in the catalytic converter of a motor vehicle. We can see the chemical reaction. 4 moles of CH3 combined with 7 moles of NO2 to form 3.5 moles of nitrogen, 4 moles of carbon dioxide and 6 moles of water. Which row gives the energy change for this reaction and a possible reason for it? As we know that in combustion reaction carbon dioxide and water are formed, so therefore they are exothermic reaction. So this reaction could also be exothermic as CH3 is converting into CO2 and H2O. We can also find out the bond energies and take a guess whether the reaction will be exo or endo. So for carbon hydrogen bond the bond energy is 410 from data booklet. For nitrogen oxygen the bond energy is not given. For nitrogen, triple bond nitrogen, the bond energy is 944 kilojoules per mole. For carbon double bond oxygen, the bond energy is 805 kilojoules per mole. For bond energy of oxygen hydrogen, it is 460 as given in the data booklet. Now, as we know that the bonds of reactants are being broken, so bond breaking is endothermic, while in product bonds are being formed, so it is exothermic reaction. So we can see that a lot of energy is being released for bond making, so therefore overall the reaction could be more exothermic as compared to endothermic. Now enough with the guesses, let's move towards the options. A is endothermic, and the reason is that chemical energy is converted into heat energy. Now we know that when chemical energy is converted into heat energy, the reaction is exothermic, it is not endothermic. So A is incorrect. B is endothermic, and the reason is that the N triple bond N bond energy is very high. Now this is a true statement because N triple bond N energy is 944 kilojoules per mole, but because of this energy the reaction becomes exothermic because N2 bond is being formed. It does not become endothermic. So B is incorrect. For C we have exothermic reaction, and the reason is that CO2 and H2O have negative enthalpy change of formation values. As we can see that in the reaction we have nitrogen which is formed, and the enthalpy of formation of nitrogen is 0 as it is in molecular form, while for carbon dioxide and water it must be negative in order to make the reaction overall exothermic. So C could be correct option. D is exothermic, and the reason is that double bonds are broken in NO2. Now NO2 consists of one double bond with oxygen and one single bond, and when double bond is broken the reaction will become endothermic rather than exothermic, as bond breaking is endothermic in nature. The correct answer is therefore C. Question number 19, which statement is correct? A. Ammonia reacts with alkalis to form ammonium ion. Now we know that ammonia can react with acids H+ to form a coordinate covalent bond and convert into ammonium ion. So therefore A is incorrect. B is ammonium chloride contains ionic, covalent and coordinate covalent bonds. Let's draw the structure of ammonium chloride. We have one nitrogen. 3 hydrogen atoms are present as single covalent bonds, while the fourth bond with H+ is formed by donating a lone pair of electrons from nitrogen to H+. So therefore it forms coordinate covalent bond. Overall the charge on NH4 is positive, and also we have chlorides, so Cl is negative. Now we can see that ionic bond is present as there are opposite charges, also covalent bond is present and coordinate covalent bond is also present. So B could be the correct option. C. The ammonium ion reacts with acids to produce ammonia. This is incorrect because ammonium ion, for example ammonium chloride, can react with alkali to form ammonia gas. D. The bond angle in the ammonium ion is approximately 107. This is also incorrect because nitrogen is making 4 covalent bonds with 4 hydrogen atoms. So when there are 4 single covalent bonds around the central atom, the structure is tetrahedral and bond angle is 109.5. So D is also wrong. The correct answer is therefore B. Question number 20. The diagrams show 2 different compounds. This is the first one, this is the second one. What is the total number of structural isomers including compound 2 that could be formed by adding a second methyl group? to the ring of compound 1. Second is we have to find out the number of pi electrons in each compound. Let's see the difference between compound 1 and compound 2. In compound 1 we had just one methyl group attached in the ring, while in compound 2 this one is the same as compound 1, while this one has been added, and it is also a CH3 group. So we can assume that this CH3 has replaced hydrogen atom from the carbon, and it is attached now with the carbon atom. Let's look at how many hydrogen atoms are present on the ring. So with this carbon, the fourth bond will be with hydrogen atom. This carbon is making two bonds with carbon, so there will be two hydrogen atoms present. Again, with this carbon there are two hydrogen atoms present. Similar with this one. This carbon is making three bonds, and fourth one is hydrogen, and this carbon does not have any hydrogen atoms left. Now we can see that CH3 has replaced one hydrogen atom and it is attached with this carbon. Now CH3 can also replace this hydrogen atom and gets attached with this carbon atom. It can also replace one of hydrogen atom from this carbon. Similarly, one hydrogen atom from this carbon can be replaced, and one hydrogen atom from this carbon can also be replaced. So in total we have 5 positions at which CH3 can be attached. This is first, second, this is third, this is fourth, and this is fifth one. We cannot attach with this carbon atom because already a methyl group is attached and there is no hydrogen atom left to replace. Also, you can see that one hydrogen atom was present on this carbon atom, but it is not included, as in the question they have just mentioned the ring. So we are only going to take the hydrogen atoms of the ring. Second is the number of pi electrons in each compound. As we can see that the double bonds are still present, so there are 2 pi bonds, and in total there will be 4 pi electrons. So the number of possible isomers are 5, because CH3 can be attached with the 5 carbon atoms, and the number of pi electrons is 4, as we have 2 pi bonds. The answer is therefore D. Question number 21. Which compound has the molecular formula C6H10O? Now this is a simple question. You just have to find out the number of carbon atoms, hydrogen atoms, and oxygen atoms. Let's move to the first option. We have 1, 2, 3, 4, 5 carbons in the ring, and 1 is outside the ring, so there are 6 carbons in total. Similarly for B, we have 1, 2, 3, 4, 5, 6 carbons. Again in C, we have a ring of 6 carbon atoms. And in D, we have 1, 2, 3, 4, 5, 6 carbons. Now let's find the number of hydrogen atoms. As we can see that this carbon is making 4 bonds, so there are no hydrogen atoms attached to this one. This one is making 2 bonds, so there are 2 hydrogen atoms. This one is making 3 bonds, so 1 hydrogen atom is present. Similarly, 3 hydrogen atoms are present with this one, 2 with this one, and 2 with this one. So in total we have 10 hydrogen atoms, and also 1 oxygen is present. So the formula is C6H10O. So A could be the correct option. In B, we have 3 hydrogen atoms with this carbon. As it is making single bond, so there are 3 hydrogen atoms, so in total it becomes 4 bonds. Similarly, 3 with each corner carbon. And this central carbon is making 4 bonds. Similarly, this carbon is also making 4 bonds. So in total we have 12 hydrogen atoms, and 1 oxygen is also present. So B is incorrect. In C, we can see that this carbon is making 2 bonds, so there are 2 hydrogen atoms attached. This one is making 3 bonds, so there is 1 hydrogen atom. Again 1 with this one, 2 with this, and 2 with this one. So in total we have 8 hydrogen atoms, and again 1 oxygen is present. So C is also incorrect. In D we have 3 hydrogen with this corner carbon, 2 with this one as it is making double covalent bond. This one is making 4 bonds. As 1 hydrogen atom is present here, so in total we have 12 hydrogen atoms. Also 1 oxygen is present. So D is also incorrect. Correct answer is therefore A. Question 22. What is the structural formula for the major product when hydrogen bromide reacts with 2-methyl-but-2-ene? Let's draw the structure of 2-methyl-but-2-ene. In long chain we have 4 carbon atoms as it is but. On second carbon we have methyl group attached, so we can write CH3. Again it is 2-ene, so it means between second and third carbon there is a double bond present. Rest are the number of hydrogen atoms, so 3 with this one, 1 with this, and 3 with this one. Now this reactant can react with HBr in 2 different ways. In one, this carbon is attached with the hydrogen atom and this one with bromine, while in second the steric carbon is attached with bromine atom and this one with hydrogen. The products formed will be like this: CH3, carbon, CH3. Double bond is converted into single covalent bond as addition is taking place. Now hydrogen combines with one carbon atom and Br with the other carbon atoms of the double bonded carbons, or the structure can be other way around like this. Or bromine can attach with this carbon and hydrogen will be attached to this carbon atom. Now both products are different because an intermediate carbocation can be formed on this carbon or on this carbon. The structure of intermediate will be like this. So either this carbon is forming carbocation or this carbon is making carbocation. Now we can see that with this carbon there are 2 methyl groups, 3 methyl groups in fact directly attached. So therefore this is tertiary carbocation. It is more stable as compared to this one in which carbocation is attached directly with 2 carbon atoms. So it is secondary carbocation. Now among HBr, hydrogen is partial positive and bromine is partial negative. So partial negative will move towards carbocation and it will form major product with the one that is more stable. So therefore this product will be a major product and this product will be minor product. Now this is taking place under Markovnikov's rule. Let's find the structure of the major product. So we have 2 CH3 with this carbon atom, so we can write CH3 twice. Then we have C. Then bromine is also attached with this carbon, so we can write bromine in bracket. Then we have CH2 and then CH3. Now moving towards the given options, we can see that this one is similar to our product formed, so therefore answer is B. Question 23. Which reaction is most likely to involve the formation of a positively charged intermediate? We have 1-bromopentane in warming with dilute NaOH. In second, again we have halogenoalkane and it is formed with dilute NaOH. Again in third one, same reaction takes place, and same is in the fourth one. Now you should remember that with dilute NaOH and warming, what happens that the halogen is replaced with hydroxide from sodium hydroxide. Let's do the reactions. In A we have 1-bromopentane. So in long chain we have 5 carbon atoms as it is pentane and all bonds are single covalent bonds. And on first carbon atom we have bromine atom attached. Now as this is a primary halogenoalkane, because this carbon is directly attached with one carbon atom, so at the same time OH will attack this partial positive carbon, and at the same time this bond will be broken. So this involves SN2 mechanism and no intermediate carbocation is being formed. B is 1-bromo-2,2-dimethylpropane. So in the long chain we have 3 carbon atoms. On first we have bromine. On second we have 2 times methyl. So one CH3 group here and one is over here. On carbon atom we have partial positive charge, and on bromine we have partial negative as it is more electronegative. Again we can see that this carbon is attached directly with one carbon atom, so it is a primary halogenoalkane. So no intermediate carbocation is formed. There will be a direct reaction in which OH will attack with this carbon and this bond will be broken. So this also follows SN2 mechanism. C is 1-bromo-3-methylbutane. In long chain we have 4 carbon atoms as it is butane, and on first carbon we have bromine, while on third carbon we have methyl group. Again you can see that this carbon is directly attached with one carbon atom, so it is primary halogenoalkane, and there will be no intermediate formed that consists of carbocation. So as this is primary halogenoalkane, it follows SN2 mechanism. Now let's move to the last one. We have 2-bromo-2-methylbutane. Again in long chain we have 4 carbon atoms. On second carbon atom we have bromine. Again on second we have methyl. Now you can see that the carbon atoms attached with bromine is attached with 3 carbon atoms directly. So this is tertiary halogenoalkane in which carbon is partial positive and bromine is partial negative. Now what happens is that the attack of OH negative on tertiary halogenoalkane is not possible because there is steric hindrance, as there are 3 CH3 groups surrounding this partial positive carbon. So what will happen that in first step carbocation intermediate is formed and bromine bond will be broken. This carbon will become positive and bromine will be removed in the form of Br negative. In second step what happens that OH will now attack on this positive carbon atom and product is formed. So we can see that in D carbocation is formed, so therefore D is correct. Question 24. The infrared spectrum of a substance with empirical formula C2H4O is shown. Which bonds are responsible for peak X and peak Y? Now we can see that peak X is around nearer to 3000, while peak Y is around 1700 plus. Let's move towards option. For peak X, we have two options. One is CH and one is OH. Now from data booklet, we know that carbon-hydrogen peak comes around 2850 to 2950 per centimeter, while alcohol peak OH is present around 3200 to 3600 per centimeter. As we can see that no peak is present between 32 and 3600, so therefore it could be A or B. Similarly, looking at peak Y, we have carbon double bond carbon and carbonyl carbon. Now carbon double bond carbon comes from alkene and the peak is around 1500 to 1680 and it is weak peak, while we can see that this peak is very strong as the percent transmittance is very low, so therefore it is not C double bond C peak, it could be carbonyl carbon. Now carbonyl carbon peak is around 1670 to 1740 per centimeter sharp or strong. So it could be carbonyl, as in B both options are correct, so therefore this is the answer. Question number 25, the structure of conene is shown. This is the compound conene. Conene can be synthesized by reacting ammonia with dibromo compound X. This is the chemical reactions in which this thing reacts with ammonia to form conene along with 2HBr. What is the name of compound X? As we can see that 2HBr are removed and we had a reactant called NH3. So in NH3, 3 hydrogen atoms are present. As in compound X, there were 2 bromine atoms and now in conene there is no bromine atom. So therefore bromine atom has been replaced along with hydrogen atom. So it means that a substitution reaction has taken place and nitrogen has bonded itself with carbon atoms. Now we can see that one hydrogen atom is still present with nitrogen while one bond is formed with this carbon while the other bond is formed with this carbon. We can say that originally this compound was like this. It consists of one bromine atom on this carbon and one bromine atom with this carbon, and rest were 3 carbon atoms that are still present. Now what has happened that ammonia has formed a substitution product and this Br along with this hydrogen and this Br with this hydrogen atom has been removed and new bond is formed with nitrogen and these carbon atoms. Let's look at the number of carbon atoms. We have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 carbon atoms. So this is octane. And we can see that one bromine is attached with the first carbon atom while second bromine is attached with the 5th carbon atoms. So we can write 1, 5 dibromo octane. Let's look into the options. In D we have 1,5 dibromo octane, so therefore D is the correct answer. Question number 26. Structural isomerism and stereoisomerism should be considered when answering this question. 3-methylhexane 3-ol reacts with hot concentrated sulfuric acid to form several isomeric compounds with the molecular formula C7H14. How many isomeric compounds could be formed in this reaction? In the reactants we have 3-methylhexane 3-ol. As this ends in ol, so therefore it is an alcohol. And now we know that what happens when hot concentrated sulfuric acid is reacted with alcohol, actually water molecules is removed. So this is a dehydration reaction. Now we can see that OH is present with this carbon atom and hydrogen will be removed from adjacent carbon, which could be this one or this one or this one, as all three are adjacent to this OH carbon. So when hydrogen atom from adjacent carbon is removed and OH from this carbon is removed, it will form an alkene. So three different alkenes can be formed. Now first possible product could be this one. Now in this product we can see that this carbon atom is attached with two hydrogen atoms, and as both atoms are similar, so therefore no cis trans is possible, only this product is formed. As both hydrogen atom attached with a double bonded carbon is same, so therefore cis trans isomer is not possible. In the second product, the double bond could be present between these two carbon atoms. If hydrogen atom is removed from this one and OH is removed from this carbon. Now we can see that with double bonded carbon atoms, two different groups are attached with this carbon, and again one hydrogen atom and one CH3 is attached with this carbon, so therefore cis trans isomerism is possible. So one product will be cis and second will be trans. For the third product, the double bond will come between these two carbon atoms. So again we can draw the structure. You can see that the double bonded carbon is bonded with two different groups, and this double bonded carbon is attached with one hydrogen atom and one is this group. So again cis trans is possible. No other product is possible, so therefore we have 1, 2, 3, 4, 5 possible isomers formed. The answer is therefore C. Question 27. An organic compound T undergoes the following reactions. First is that it is oxidized by a hot acidified potassium manganate 7. Second is that it reacts with sodium to give hydrogen gas. What could be compound T? A is given. Let's draw the structure. We have 4 carbon atoms and with third carbon OH is attached. This is secondary alcohol, as we can see that this carbon is directly attached with 2 other carbon atoms. Now for secondary alcohol, when it is oxidized with acidified potassium manganate, it forms ketone. And it can also react with sodium to give hydrogen, and sodium alkoxide is formed, which is like this. Now this hydrogen atom is replaced and it forms hydrogen gas. So A gives both reactions, so therefore this could be the possible option. Let's draw B. In B we can see that it is aldehyde functional group and there are 4 carbon atoms. Now aldehyde can be oxidized by hot acidified potassium manganate to form carboxylic acid. So the product will be like this. But aldehyde cannot react with sodium metal to give any product. So B is incorrect. In C we can see that again we have alcohol. Let's draw the structure. As we can see that with this carbon atoms, 3 carbon atoms are directly attached, so this is tertiary alcohol. And you should know that tertiary alcohol does not oxidize to form any product, while it can react with sodium metal to form sodium alkoxide. Along with hydrogen gas. So as only one reaction is possible, so therefore this is incorrect. Now moving towards the last one, we have ketone functional group and there are 4 carbon atoms. Now ketone cannot be further oxidized in a chemical reaction, and it also does not react with sodium metal to form any product. So D is also incorrect. The correct answer is therefore A. Question number 28. Compound X is treated with two reagents successively forming compound Z. This is compound X. We have aldehyde functional group, alkene functional group is also present, and ketone functional group is also present. The first reaction is with a mild oxidizing agent and it forms Y, while second reaction is with sodium tetrahydroborate, which acts as a reducing agent to form compound Z. Let's look at what happens in the chemical reaction. When mild oxidizing agent is reacted, what happens that the aldehyde gets oxidized to carboxylic acid, while alkene and ketone does not get oxidized. So product Y will be like this. Alkene is present, ketone is also present, while aldehyde has converted into carboxylic acid. Second reaction is with NaBH4, which is sodium tetrahydroborate, and it acts as a reducing agent. So now we can see that alkene is not reduced. Carboxylic acid cannot be reduced by this reagent. Only ketone is reduced back to secondary alcohol. So the product Z formed will be like this. We have COOH still present, alkene is still present, while ketone is converted into secondary alcohol. We can also draw this product like this. We have CO2H, alkene, and with this carbon atom we have OH functional group and CH3. So now we can see that the correct answer is A. Question number 29. Which reagent may be used to distinguish between propanone and ethanol? Propanone is ketone and it consists of carbonyl carbon atom, while ethanol is alcohol and it consists of OH functional group. A is 2,4-dinitrophenylhydrazine, which is also called 2,4-DNPH, and it can give positive results both with aldehyde and ketone because of the presence of carbonyl carbon. So therefore ketone will give positive result with 2,4-DNPH. While alcohol does not react with 2,4-DNPH, so therefore this can be used to distinguish between these two. B is bromine water, and bromine water can be used to identify alkenes. It cannot react with alcohol or ketone, so therefore B is incorrect. C is Phelan's reagent. Now Phelan's reagent can react with aldehyde, not with ketone, and not with alcohol. Similarly, Tollens reagent can also react with aldehyde but not with ketone or alcohol, so therefore these cannot be used to differentiate between these two. So C and D is incorrect. The correct answer is A. Question number 30. Which compound is chiral? Now among these given compounds, the compound that will be chiral is the one having carbon atoms attached with 4 different groups. The groups can be compound or elements. Let's draw the structures. A is 1-chloro-3-methylbutane. So we have 4 carbon atoms in the long chain as it is butane. On first carbon we have chlorine atom attached, and on third carbon we have methyl group. Rest are the number of hydrogen atoms. Now we can see that with first carbon atom, two similar atoms are present, so therefore this is not chiral. Again, with third carbon atom, you can see that two methyl groups are attached which are similar, so therefore none of the carbon atom is chiral. B is 2-chloro-2-methylbutane. Now let's draw the structure. Again, we have 4 carbon atoms in the long chain. On second carbon we have chlorine, and on second carbon again we have methyl functional group. So as you can see that both these are same, so therefore this is not chiral. Moving towards C, we have 2-chloro-3-methylbutane. Again 4 carbon atoms in the long chain. On second carbon atom we have chlorine. On third carbon atom we have methyl. As we can see that this carbon atom is making 3 bonds, so the fourth bond will be with hydrogen. So we have 1 hydrogen, 1 methyl group, 1 chlorine, and 1 is this group. So therefore this is chiral compound. So C is correct. D is 3-chloropentane. In pentane we have 5 carbon atoms in the long chain. On third carbon atom we have chlorine. Also on third carbon atom we would have hydrogen atom attached, and as you can see that both these are similar, so therefore this is not chiral. Correct answer is therefore C. Question number 31. An atom of calcium 48 can form a 2 positive ion. Which statements about this ion are correct? The atomic mass of calcium is given, it is 48. So we can write 48. From periodic table we know that the atomic number of calcium is 20. So the number of protons is equal to 20. While the number of neutrons is equal to mass number minus atomic number. As the charge is given as 2 positive, so therefore 2 electrons are lost. So the number of electron is 20 minus 2 equals 18. Option 1, it has 20 protons. This is correct. Option 2, it has 28 neutrons. This is also correct. Option 3, it has 22 electrons. This is wrong. The answer is therefore B. Question number 32. 4 elements W, X, Y and Z have electronic configuration as shown. Which formula represents compounds that have boiling points below room temperature? Now W has 4 electrons in the outermost shell, so therefore it belongs to group 4 of the periodic table. And as in total we have 6 electrons, so it could be carbon. X is in group 6 of the periodic table, and in total we have 8 electrons, so there must be 8 protons, so it could be oxygen. Y is in group 2 of the periodic table, and in total there are 12 electrons, so there could be 12 protons. So Y could be magnesium because magnesium atomic number is 12. Similarly, Z belongs to group 1 of the periodic table, so it could be potassium as the atomic number is equal to 19. First one is WX2, so we have CO2, and CO2 is a gas at room temperature, so it could be correct. Second is YX, Y is magnesium and X is oxygen, so formula is MgO, and MgO is solid at room temperature. Third is Z2X, as Z is potassium and X is oxygen, so it could be potassium oxide, and again it is solid at room temperature. The correct option is only 1, so therefore answer is D. Question 33. Which statements about enthalpy changes are correct? 1. The enthalpy change of atomization is always positive. This is true statement because Atomization is the conversion of element or molecule into atoms, and it requires energy in order to break the intermolecular bonds or forces. For example, carbon solid can be converted into carbon gas upon heating. So therefore the change is endothermic. Option 2, the enthalpy change when a carbon-carbon bond is broken is positive. Now this is also true because bond breaking is always endothermic. As it always requires energy to break a chemical bond. 3. The enthalpy change of neutralization of weak acid is always negative. Now neutralization is the reaction in which acid reacts with alkali to form salt and water. And whether the acid is weak or strong, the enthalpy change is always negative as the energy is released. As all three options are correct, so therefore answer is A. Question 34. Vanadium and pepsin can both act as catalyst. Vanadium is a metal, pepsin is an enzyme. Which statements are correct for both vanadium and pepsin? 1. They will speed up any chemical reaction. Now we know that catalysts are reaction specific. It means that vanadium is reaction specific, so therefore it will behave as a catalyst in one of the chemical reaction, while in other chemical reactions it cannot be used as catalyst. Similarly, pepsin can be used as an enzyme and it is also reaction specific, so therefore it can be used for only one type of chemical reactions, not for any chemical reaction. So first option is incorrect. Number 2, they can lower the activation energy for a reaction. Now this is true statement because catalyst speeds up the chemical reaction only by lowering the activation energy, and this is also true for enzyme. 3 is they are not used up when they act as catalyst. This is true because catalyst is not used up in a chemical reaction. It will still be present in the product unaltered. So option 2 and 3 are correct. Therefore answer is C. Question number 35. Which oxides when placed in cold water for 1 day will react with water? First is magnesium oxide, and we know that magnesium oxide reaction with cold water is very slow and it will form magnesium hydroxide eventually. Second is aluminum oxide. This one is insoluble in water. Third is silicon dioxide. Again, this does not dissolve or react with water. So only option 1 is correct, so therefore answer is D. Question 36. A mixture of magnesium carbonate and magnesium nitrate is heated strongly in a hard glass test tube. Which gases are formed? Let's write the chemical reaction for magnesium carbonate decomposition. So upon decomposition, magnesium oxide is formed along with carbon dioxide gas, which is released. Similarly, magnesium nitrate will also decompose upon strong heating, and it will form magnesium oxide along with nitrogen dioxide and oxygen gas. So we can see that carbon dioxide is formed. Nitrogen dioxide is also formed. Oxygen gas is also formed. As all three options are correct, so therefore answer is A. Question 37. Which statements about polyalkenes are correct? Now polyalkene is a polymer that is formed from alkene monomer. In polyalkene, all carbon-carbon single bonds are present along with hydrogen atoms attached with the carbon atoms. Number 1, polyalkenes do not react with bromine in the dark. Now in the dark, what happens that bromine does not get converted into radicals, so therefore reaction will not occur. So this is a true statement. 2, disposable of polyalkenes by combustion can produce harmful products. This is also a true statement because the combustion of polyalkenes form very toxic compounds such as dioxins. 3, polyalkenes do not readily biodegrade. This is also a true statement because the bonds present in polyalkenes are strong bonds and therefore they cannot be easily biodegraded by bacteria or microorganisms. As all 3 statements are correct, so therefore answer is A. Question 38. Compound Y reacts with alkaline aqueous iodine to form a yellow precipitate. Changes the color of warm acidified potassium dichromate 6 solution. From first reaction, we can infer that compound Y consists of CH3C double bond O or CH3COH. Because only these groups, if present in a compound, will give positive result with alkaline aqueous iodine. For second options, we can infer that this compound can be further oxidized. Let's draw the structures. For first, we can see that there are 2 carbon atoms and 1 OH group is attached. So this is primary alcohol. And primary alcohol can be oxidized to aldehyde. So second statement is true for this one. Also we can see that CH3COH is present, which is responsible for yellow precipitate of alkaline aqueous iodine reaction. So therefore option 1 is correct. Now in compound 2 we can see that we have 2 carbon atoms and also it is an aldehyde. This can be oxidized into carboxylic acid. And also we can see that this group is present, which is responsible for yellow precipitate formation. So 2 is also correct. For third compound, we can see that there are 3 carbon atoms and it is a ketone. So we can write CH3, C double bond O, CH3. Now ketone cannot be further oxidized. So therefore it won't change the color of acidified potassium dichromate. But it does consist of CH3C double bond O, which is responsible for yellow precipitate in first chemical reaction. So only one result is positive. The answer is therefore B. Question 39. Carboxylic acids can be made by several different reactions. Which statement are correct? First is the acid hydrolysis of CH3CH2CN. This is propane nitrile. Will make ethanoic acid. The acid hydrolysis of propane nitrile will be like this. We have propane nitrile. It is hydrolyzed in the presence of acid to form carboxylic acid. And as we have 3 carbon nitrile, so therefore 3 carbon carboxylic acid will be formed. So propane nitrile will form propanoic acid instead of ethanoic acid, so 1 is incorrect. 2. The oxidation of CH3CH2CH2CH2OH, this is an alcohol, will make butanoic acid. Now this is primary alcohol and we know that primary alcohol will first oxidize to aldehyde and then convert into carboxylic acid. The reaction will be like this. The ultimate product is carboxylic acid, which is also of 4 carbon. So this is true. 3 is the oxidation of aldehyde to make propanoic acid. As this is 3-carbon aldehyde, so 3-carbon aldehyde can be oxidized to form 3-carbon carboxylic acid. So this statement is also true, as option 2 and 3 are correct, so therefore answer is C. Question 40. Carboxylic acids reacts with alcohol to produce esters. Carboxylic acid X forms one ester only with molecular formula C5H10O2. What could X be? As we can see that the molecular formula of ester is C5, so it consists of 5 carbon atoms. In ethanoic acid we have 2 carbon atoms. So we will need 3 carbon alcohol, which is propanol, in order to form 5 carbon ester. Now this 3 carbon alcohol can also be secondary alcohol instead of primary. Rest are the number of hydrogen atoms. Now the ester formed can be like this. Now we have 3 carbon alcohol. Or it could be like this if secondary alcohol is used. The molecular formula of both these compounds is C5H10O2. Therefore, 2 different esters are formed, so one is incorrect. Second is propanoic acid. In propanoic acid, we have 3 carbons in carboxylic acid. So it means that it needs 2 carbon alcohol in order to form 5 carbon ester. Rest are the number of hydrogen atoms. And this is the only way in which 2 carbon alcohol can be drawn, so there is only one product that is formed. So from 3 carbon carboxylic acid and 2 carbon alcohol, this product is formed whose molecular formula is C5H10O2. So only one type of ester is formed, so therefore propanoic acid is correct. Now moving towards butanoic acid. Again, butanoic acid is the one having 4 carbon atoms, and we would need 1 carbon alcohol in order to form ester. There is just one way in which alcohol could be drawn, so therefore only one ester product is formed. Rest are the hydrogen atoms. The molecular formula of product is C5H10O2. So 3 is also correct. The answer is therefore C. Thank you for watching. Don't forget to like, subscribe and share. Stay tuned for more upcoming videos. Stay happy. Take care.